Close your eyes for a moment. Take a deep breath. Imagine standing on the very edge of the world. Now push that edge further out. Millions of miles, billions of miles, far past the warming glow of our sun. Welcome to the twilight zone of the solar system. For decades, this distant realm was nothing more than a dark, silent mystery, a place of endless night and freezing shadows. But everything has just changed. The James Webb Space Telescope, humanity's greatest eye in the sky, has just looked at Pluto for the very first time. And the results? They are nothing short of surprising. We often think of space as an empty, terrifying void. But today, we are going to change that. We are going to show you how a frozen world at the edge of nowhere can actually be a cradle of peace and breathtaking beauty. You don't need to be an astronaut to experience this. You don't need a degree in astrophysics. All you need to do is listen, relax, and let your imagination drift among the stars. Today, we are taking a journey to Pluto, and by the end of this voyage, you will see our solar system in a completely new light. Before we dive into the stunning new discoveries, let us drift back in time. It is essential to understand the quiet history of this distant world. For a long time, Pluto was merely a speck of light on a photographic plate. Discovered in 1930 by a young, patient astronomer named Clyde Tombaugh, it was hailed as the ninth planet, a tiny, icy outpost. For decades, it remained a blurry, pixelated enigma. Even our best telescopes could only see a smudge of grey. Then, in 2015, the New Horizons spacecraft flew past it at incredible speed. In a fleeting moment, it showed us a world of towering ice mountains and a massive, heart-shaped glacier. It was a revelation, but New Horizons only had a brief window to look. It saw Pluto in the visible spectrum of light, the light our human eyes can see. Now the stage is set for a new era. The James Webb Space Telescope has arrived. Webb does not look at the universe the way we do. It sees in the infrared. It sees heat. It sees the chemical fingerprints hidden in the cold dark. It peers through the cosmic dust and the chilling shadows. By turning its massive golden mirrors toward Pluto, Webb is not just taking a picture. It is reading the deeply buried secrets of a world that is far more alive than we ever dared to imagine. Let us begin this new chapter together. The golden mirrors align. Imagine a machine the size of a tennis court, floating in the absolute silence of deep space. This is the James Webb Space Telescope. Slowly, gracefully, it turns its honeycomb-shaped golden mirrors away from the distant, ancient galaxies. It focuses on something much closer to home. It is looking at the Kuiper Belt. This is a massive ring of icy debris at the edge of our solar system. Targeting Pluto is not as easy as pointing a camera. Pluto is incredibly small and incredibly far away. It is less than 1/5 the size of Earth. It sits roughly 3 billion miles away from the Sun. The precision required is staggering. It is like trying to spot a single snowflake falling in a blizzard from miles away. But Webb is designed for the impossible. Its mirrors gather the faintest whispers of light, light that has traveled for hours through the cold void just to reach the sensors. This perfectly illustrates the power of human ingenuity. We have built a mechanical eye that can see the unseen. Many people believe that telescopes only look at glowing stars or massive planets. We are about to debunk that myth right now. Webb can look at the coldest, smallest, darkest rocks in the sky, and it can make them shine with scientific data. As the first pixels begin to download, a new vision of Pluto begins to form. A vision built not on sunlight, but on the hidden thermal energy of the cosmos. Just breathing in that concept brings a sense of profound wonder. The power of infrared vision. To understand what Webb is seeing, we must understand the language of light. The universe speaks in many colors, most of which are completely invisible to us. Human eyes are beautiful, but they are limited. We only see a tiny sliver of reality. Webb sees in the infrared spectrum. Think of it like feeling the warmth of a fire on your skin, even when your eyes are closed. Infrared light reveals temperature. It reveals the vibrations of molecules. When Webb looks at Pluto, it is not looking for the reflection of the sun. The sun is just a bright star in Pluto's sky, offering very little heat or light. Instead, Webb is looking at the glow of Pluto's own icy surface. This is a brilliant example of how science changes our perspective. Imagine looking at a dark forest at night. With normal eyes, you see nothing but black shadows. But with thermal goggles, the forest lights up. You see the glowing bodies of animals. You see the heat radiating from the trees. This is exactly what Webb is doing to the edge of the solar system. It is turning the lights on in the dark. A common myth is that Pluto is just a dead, frozen rock, locked in eternal stasis. But infrared light tells a completely different story. It shows us a world that is chemically active, a world that interacts with the sparse sunlight in the vacuum of space. As we drift further into this data, let the idea of hidden light calm your mind. There is always more to the universe than meets the eye. There is always warmth, even in the deepest cold. A journey through the dark. Let us take a moment to truly appreciate the vast distance to Pluto. Imagine you are traveling at the speed of light, the fastest speed possible in the universe. Even at this incredible velocity, moving at 186,000 miles per second, it would take you over 4 hours to reach Pluto from Earth. That is how massive our solar system is. And yet, the light carrying the image of Pluto makes this journey every single day. The vacuum of space between us and Pluto is profoundly quiet. It is a vast ocean of nothingness. This sheer scale might seem terrifying at first, but let us change that perspective. This vastness is not an empty void to fear. It is a protective cushion. It is a quiet sanctuary. Out here, the noise of Earth cannot reach you. The stress of daily life simply does not exist. The only thing that matters is the gentle pull of gravity and the slow, majestic dance of celestial bodies. When James Webb captures the light from Pluto, it is capturing a messenger that has crossed this grand ocean of silence. The data we receive is a testament to the peace of the outer solar system. To illustrate this, think of a message in a bottle, tossed into the Pacific Ocean, washing up perfectly intact on a distant shore. That is the light from Pluto hitting the golden mirrors. It is a gentle reminder that we are connected to the furthest reaches of the dark. We are part of this grand, silent architecture. Peering through the haze. One of the most beautiful discoveries about Pluto is its atmosphere. Yes, this tiny, freezing world has an atmosphere. It is not like the thick, breathable air of Earth. It is a thin, delicate veil of nitrogen, methane, and carbon monoxide. When New Horizons flew by, it captured a breathtaking image of Pluto backlit by the sun. It showed a glowing blue ring around the dwarf planet. But Webb takes this a step further. Webb's infrared eyes can cut straight through this haze, or choose to analyze the haze itself. Imagine a foggy morning over a calm lake. With your eyes, you cannot see the opposite shore. The mist hides everything. But with a special radar, you could see the trees across the water perfectly. That is the power of Webb's instruments. We are analyzing the chemical makeup of these hazy layers with unprecedented detail. We are discovering that Pluto's atmosphere is structured in complex layers, like an onion. A widely held myth was that an atmosphere could not survive so far from the sun. People thought the gases would just freeze solid and fall to the ground. While some of it does freeze, a delicate balance is maintained. The atmosphere breathes. It expands when Pluto gets slightly closer to the sun, and it collapses as it moves away. It is a slow, cosmic respiration, a world that breathes over the course of centuries. Let the rhythm of that slow, atmospheric breath soothe your thoughts. Even in the freezing dark, there is movement. There is a gentle, eternal cycle. The heart of ice and shadows. Let us focus our attention on the most famous feature of Pluto, the giant, bright region shaped exactly like a heart. This area is officially named Tombor Regio. The left side of this heart is known as Sputnik Planitia. It is a massive basin, completely filled with frozen nitrogen. Imagine a glacier on Earth, but instead of frozen water, it is frozen gas. It is a landscape so alien, yet so beautiful. PEM's infrared sensors are mapping this heart with astonishing precision. It is looking for variations in the ice. It is looking for cracks, for flows, for the deep history carved into the surface. What makes Sputnik Planitia so fascinating is how smooth it is. There are almost no craters here. In the violent history of the solar system, a smooth surface means only one thing: the surface is young. It is constantly renewing itself. This shatters the myth that Pluto is a stagnant, dead world. It is geologically active. The ice is churning. It is bubbling up from below, slowly erasing the scars of meteor impacts. Think of a pot of thick soup slowly simmering on a stove. The surface constantly turns over. That is what the nitrogen ice on Pluto is doing, but over millions of years. Webb can detect the subtle temperature differences across these vast icy plains. It is mapping the convection currents of a frozen heart. It is a mesmerizing thought, a beating heart of ice, slowly churning in the silent dark of the Kuiper Belt. It is a masterpiece of planetary geology, painted in invisible light. Mountains forged in water. As we look to the edges of the great ice heart, we see something truly spectacular. Mountains, towering peaks that reach thousands of feet into the thin blue haze. But these are not mountains made of rock, like the Rockies or the Himalayas. These are mountains made entirely of water ice. Out here on Pluto, the temperature is so unimaginably cold that water ice becomes as hard as granite. It forms the bedrock of the dwarf planet. Webb's instruments are perfectly tuned to analyze the signature of water ice. It maps where these mountains rise and how they interact with the softer nitrogen glaciers around them. Picture a grand mountain range on Earth, covered in snow. Now, swap the materials. The mountain itself is the ice, and the snow is frozen nitrogen. It is a surreal and breathtaking landscape to visualize. It invites you to let your imagination wander across these rugged, frozen peaks. A persistent myth in astronomy used to be that the outer solar system was just a collection of dirty snowballs with no complex geology. Pluto's water ice mountains completely destroy that idea. They show us that complex geological forces are at work everywhere, even at the edge of the abyss. Webb is helping us understand how these mountains formed. Were they pushed up from below? Are they floating like icebergs on a denser layer of slush? The data pours in, silent and profound. Every pixel brings us closer to understanding the architecture of this distant, frozen paradise. The hidden ocean beneath. Now, we delve into one of the most thrilling mysteries of Pluto, a mystery that James Webb is helping us unravel. Below the hardened crust of water ice, beneath the churning plains of nitrogen, there may be a vast, liquid ocean. It sounds impossible. How could liquid water exist billions of miles from the warming sun? The answer lies deep within Pluto's core. Radioactive decay in the rocky center of the dwarf planet produces a faint, steady heat. This heat struggles to escape through the thick, icy shell. In the process, it may keep a subsurface layer of water in a liquid, slushy state. Webb cannot look directly through miles of solid ice, but it can look for clues on the surface. It searches for specific chemicals that might have welled up from the deep. It looks for stress fractures in the ice crust, caused by the freezing and expanding of an ocean below. Think of a frozen lake in the middle of winter. The surface is hard enough to walk on, but below, the water flows, teeming with unseen potential. This is a brilliant illustration of how planets hide their greatest secrets. We used to think that the habitable zone, the area where liquid water could exist, was strictly tied to the distance from the sun. Pluto challenges this myth entirely. It shows us that oceans can hide in the darkest, coldest corners of the galaxy, kept alive by internal warmth. Let your mind float in that hidden, silent ocean, a vast, dark sea, locked away in an eternal embrace of ice, a secret sanctuary floating in the void. Cryovolcanoes, eruptions of ice. If a hidden ocean wasn't astonishing enough, consider how that ocean might interact with the surface. Valley is turning its gaze toward regions of Pluto that look suspiciously like volcanoes. But these are not the fiery, lava-spewing volcanoes of Earth or Jupiter's moon Io. These are cryovolcanoes, ice volcanoes. When pressure builds up deep within Pluto, it does not erupt molten rock. It erupts a freezing slurry of water, ammonia, and methane. This slushy mixture flows across the freezing surface before turning instantly solid. Webb's infrared spectroscopy is crucial here. It can detect the unique chemical signatures of ammonia, which acts as an antifreeze, keeping the slush liquid at incredibly low temperatures. Imagine a majestic volcano, but instead of glowing red magma, it oozes a pale, glowing blue slush into the endless night. It is a silent, cold eruption, a slow-motion fountain of ice. This concept beautifully shatters the myth that volcanic activity requires extreme, fiery heat. Nature is infinitely creative. It finds a way to release energy, whether it is thousands of degrees hot or hundreds of degrees below zero. By studying these cryovolcanoes, Webb is reading the pulse of Pluto. It is proving that this tiny world is geologically alive and kicking. The very idea of ice volcanoes brings a sense of quiet awe. It is a paradox of nature, existing in perfect harmony. Fire and ice rewritten for the outer solar system. The strange snow of the underworld. Let us look closer at the colors of Pluto. In visible light, we see patches of bright white, deep red, and dark brown. But what creates these colors? The secret lies in a complex chemical reaction happening high in the atmosphere, slowly drifting to the ground. These colors are created by tholins. Tholins are complex organic molecules formed when ultraviolet light from the distant sun hits methane and nitrogen in Pluto's atmosphere. Over time, these molecules clump together and fall to the surface like a strange reddish snow. Webb is exceptionally good at identifying these organic compounds. Its infrared sensors map the distribution of tholins across the vast plains and deep craters. Think of a gentle snowfall on Earth, pure and white. Now, imagine a snowfall that takes years to reach the ground, painting the icy mountains in a deep, rusty red. It is a slow, cosmic painting process. A common myth is that organic molecules, the building blocks of life, are rare in the universe. In reality, they are abundant. Pluto is covered in them. Webb's observations help us understand how these complex molecules form in such extreme cold. It shows us that the chemistry required for life is not confined to warm, wet planets. It is happening right now in the freezing dark, slowly dusting the surface of a dwarf planet. As you visualize this eternal red snowfall, feel the deep tranquility of a process that takes millions of years to unfold, a quiet masterpiece in the dark. Charon, the loyal companion. Pluto does not travel through the dark alone. It is accompanied by a massive moon named Charon. In fact, Charon is so large compared to Pluto that they are often considered a double-planet system. They are locked in an eternal, intimate dance. Webb's incredible resolution allows it to look at Charon with just as much detail as Pluto. It is comparing the two worlds, looking for similarities and stark differences. While Pluto is painted with red tholins and bright nitrogen ice, Charon is mostly covered in grey, ancient water ice with a dark red stain on its north pole. This polar cap is deeply fascinating. Scientists believe that Charon captures the atmosphere escaping from Pluto. The methane drifts over, freezes at Charon's pole, and is baked by sunlight into red tholins. It is a beautiful illustration of sharing in the cosmos. One world bleeds its atmosphere, and its partner catches it, wearing it like a crown. A long-held myth was that moons are always much smaller and entirely dominated by their host planet. But Pluto and Charon challenge this. They orbit a common center of gravity in the empty space between them. They face each other constantly, locked in a mutual tidal embrace. It is a perfect, silent partnership. Webb captures the thermal glow of both worlds simultaneously. As you imagine this binary system spinning silently through the Kuiper belt, think of the harmony it represents. A perfect balance of gravity and motion, moving together through the eternal night. The dance of the tiny moons. Beyond the great companion Charon, Pluto has a small, chaotic family. 4 tiny moons dance around the central pair. Their names belong to mythology: Nyx, Hydra, Kerberos, and Styx. They are small, irregularly shaped blocks of ice, tumbling wildly through space. James Webb, with its unmatched sensitivity, can detect the faint infrared signatures of these distant, tiny rocks. Observing them is a masterclass in cosmic observation. Because they are so small and far away, catching their light is like trying to photograph dust motes floating in a dark room, illuminated only by a single candle. These moons do not orbit smoothly. Because of the complex, shifting gravity of both Pluto and Charon, the small moons tumble and spin unpredictably. They are caught in a restless, eternal ballet. This breaks the myth that everything in the solar system operates like a perfect, ticking clock. There is chaos in the cosmos, but it is a beautiful, contained chaos. Webb helps us analyze the surface composition of these tiny moons. Are they chunks of Pluto that broke off during an ancient collision, or are they wanderers from the Kuiper belt, captured by Pluto's gravity? By studying the faint heat they emit, we can uncover their origins. Let your mind drift among these tumbling ice blocks. They are the silent observers of the great Pluto-Charon dance. Small, resilient travelers, reflecting the faint light of a distant sun. They remind us that even the smallest objects have a story to tell. Decoding the infrared spectrum. What exactly does a James Webb spectrum of Pluto look like? It is not just a picture, it is a graph, a beautiful, complex waveform that tells a story of chemistry. When Webb gathers light, its spectrographs split that light into a rainbow. But this is an infrared rainbow, invisible to the human eye. Different molecules absorb different wavelengths of light. By looking at the missing pieces in the rainbow, scientists can read the exact chemical composition of Pluto's surface and atmosphere. It is like reading a cosmic barcode. Imagine you have a locked safe, and the only way to know what is inside is by listening to the sound it makes when you tap it. The spectrum is that sound. It is a highly precise illustration of planetary forensics. A common myth is that we have to physically touch a planet to know what it is made of. Webb proves that light itself carries all the physical evidence we need. When the data arrives on Earth, it looks like a series of peaks and valleys on a screen. But to a trained eye, those peaks sing the songs of methane, carbon monoxide, and water ice. It is the music of the spheres, translated into data. This gentle scientific process is a calming reminder of human achievement. We can sit comfortably on our warm blue planet and precisely measure the frost on a rock 3 billion miles away. It is the ultimate expression of our connection to the universe. The extreme cold of the underworld. Let us take a moment to truly feel the environment Webb is observing. The temperature on Pluto is difficult for the human mind to comprehend. It plunges to around -380 to -400 degrees Fahrenheit. That is roughly -230 degrees Celsius. At these temperatures, the physical world behaves in alien ways. The air freezes solid and falls as snow. Rock-hard mountains are made of water. This extreme cold is precisely why we need James Webb. Webb itself must operate at incredibly low temperatures to function. Its mirrors and sensors are shielded behind a massive sun shield, keeping them near absolute zero. If Webb were even slightly warm, its own heat would blind its infrared sensors. It is a beautiful synergy, a freezing telescope perfectly designed to look at a freezing world. Think of stepping out into a crisp winter night. The air is sharp and perfectly still. Now, multiply that stillness by 1,000,000. That is the environment of Pluto. It is not a harsh, violent cold. It is a preserving, eternal cold. It locks the history of the solar system in perfect stasis. This shatters the myth that extreme environments are inherently destructive. Sometimes, extreme cold is the ultimate preserver. It creates a museum of the ancient cosmos. Let the thought of this absolute, quiet chill wash over you. It is a pure, silent environment where time itself seems to slow down to a gentle crawl. The changing seasons of a long year. Time works differently at the edge of the solar system. A single year on Pluto, the time it takes to orbit the Sun, lasts for 248 Earth years. Because of its highly elliptical, stretched-out orbit, its distance from the Sun changes drastically over this long year. This creates intense, bizarre seasons. When Pluto is closest to the Sun, its icy surface sublimates, turning directly from a solid into a gas, thickening the atmosphere. When it moves further away, the atmosphere slowly freezes and collapses back to the ground. James Webb is observing Pluto as it slowly moves further away from the Sun. We are watching the beginning of an incredibly long winter. An illustration of this would be watching a beautiful, delicate flower slowly close its petals as the evening approaches. But this evening lasts for over a century. A persistent myth is that planets far from the Sun are frozen and completely unchanging. Pluto's dramatic seasons prove this entirely wrong. It is a dynamic world, responding to the faint whispers of solar energy. Webb's continuous observations will allow us to track these changes over time. We will watch the atmosphere thin out. We will watch the bright frost settle over the dark red plains. It is a slow, majestic transformation. As you breathe slowly, match your rhythm to the century-long seasons of Pluto. Feel the slow, sweeping changes of a world that operates on a timescale far beyond our human lives. The giant of the Kuiper Belt. To fully appreciate Pluto, we must understand its neighborhood. Pluto is not just a lonely wanderer. It is the undisputed king of the Kuiper Belt. This is a vast, donut-shaped region beyond Neptune, teeming with millions of icy bodies. These are the remnants of the solar system's formation, the leftover building blocks that never became full-sized planets. When James Webb looks at Pluto, it is not just studying one dwarf planet. It is studying the Rosetta Stone of the Kuiper Belt. By understanding how Pluto's ice behaves, how its atmosphere forms, and how its chemistry works, we unlock the secrets of thousands of other icy worlds. Imagine exploring a vast, uncharted ocean and finally finding the largest, most complex island. Studying that island tells you about the entire ocean. That is what Pluto is to us. Many people were upset when Pluto was reclassified as a dwarf planet, feeling it was a demotion. But in reality, it was a promotion. We debunked the myth that it was just the weirdest, smallest planet. Instead, it became the most magnificent and complex object in an entirely new zone of the solar system. Webb's observations confirm its royal status. It is the shining beacon of the deep dark. As we gaze into the infrared data, we are gazing into the ancient past, seeing the raw materials that built our cosmic home. It is a quiet, frozen graveyard of planetary building blocks, holding the ultimate secrets of our origins. The symphony of nitrogen. Let us zoom back in on the surface, specifically on the massive plains of Sputnik Planitia. The ice here is predominantly nitrogen. On Earth, nitrogen is a gas. It makes up nearly 80% of the air we breathe. But on Pluto, it is a vast, flowing ocean of solid white. Webb's incredible sensors are highly attuned to the specific wavelength of nitrogen frost. What it reveals is a surface that is complex and beautifully textured. The nitrogen ice is divided into giant, irregular polygons, stretching for miles across the plains. These shapes are created by the slow convection of the ice from below. Imagine a giant geometric mosaic, slowly shifting and reshaping itself over hundreds of thousands of years. It is a stunning visual to hold in your mind, a grand, frozen puzzle that never stops moving. A common myth about ice is that it is rigid and brittle. But on a planetary scale, under the right conditions, ice flows like thick honey. Webb allows us to map the temperature gradients across these nitrogen cells. We can see where the warmer ice is rising in the center and where the colder ice is sinking at the edges. It is a silent symphony of thermal dynamics, a slow, eternal churn. Let the image of these vast, geometric planes calm your racing thoughts. There is a deep, mathematical order to the universe, even in its most remote and freezing corners, a perfect, slow-motion ballet of frozen gas. The faint glow of a distant sun. Have you ever wondered what daylight looks like on Pluto? It is a question that James Webb's data helps us contextualize. Because Pluto is billions of miles away, the sun is no longer a large, blinding orb in the sky. It is merely a very bright star. The light it casts is drastically reduced. At high noon on Pluto, the brightness is roughly equivalent to the light on Earth during a cloudy twilight, just after the sun has set. It is a perpetual, calming dusk. Webb does not rely on this faint, visible light, but understanding it helps us picture the world. Imagine standing on the nitrogen glaciers of Sputnik Planitia. The sky above is black, even during the day, with the stars clearly visible. The landscape around you is bathed in a soft, silvery twilight. The harsh glare of the earthly sun is gone. It is replaced by a gentle, diffuse glow. This shatters the myth that the entire solar system is flooded with bright, blinding light. The outer realms are draped in a comforting, permanent twilight. This faint light creates long, stretching shadows across the ice mountains, giving the terrain incredible depth and texture. It is a landscape designed for quiet contemplation, a world where the harshness of the day never arrives. Let your mind rest in this eternal twilight. Feel the coolness of the silvery light. It is a perfect, peaceful environment, far removed from the chaotic energy of the inner solar system. Searching for rings in the dark. Does Pluto have rings? It is a fascinating question, and one that James Webb is perfectly equipped to answer. We know that the giant planets like Saturn, Jupiter, Uranus, and Neptune all have ring systems. Even some small asteroids in the outer solar system have been found to have faint rings. So, what about the king of the Kuiper belt? When tiny meteorites strike Pluto's small moons, they kick up clouds of dust. Because the gravity of these moons is so weak, the dust escapes into space. Scientists have long theorized that this dust might form a faint, ethereal ring system around Pluto and Charon. Webb's infrared cameras are exquisitely sensitive to thermal radiation from cosmic dust. Imagine a halo of ultrafine, glowing dust wrapping silently around the dancing binary planets. It would be a delicate, ghostly structure. A myth we often hold is that rings must be massive and bright like Saturn's. But the universe is full of subtle, nearly invisible structures. Webb is staring into the dark space around Pluto, patiently gathering photons, looking for the telltale glow of a dust ring. Whether it finds one or not, the search itself is beautiful. It represents our relentless curiosity, our desire to map every detail of our cosmic neighborhood. Let your imagination paint a faint, glowing ring around the dark world of Pluto, a delicate crown for the ruler of the icy depths. It is a vision of quiet elegance in the vast emptiness. The contrast of light and dark. One of the most striking features of Pluto, which Webb's infrared data highlights beautifully, is the extreme contrast on its surface. We have talked about the bright, churning ice of the heart, but right next to it lies a region of deep, ancient darkness. This area is known as Cthulhu Macula. It stretches halfway around the equator of the dwarf planet. While the heart is young and bright, Cthulhu Macula is heavily cratered and incredibly dark. It is covered in a thick layer of the reddish-black organic tholins we discussed earlier. The transition from the bright nitrogen plains to this dark, ancient terrain is sudden and dramatic. Webb's instruments map this boundary with incredible precision, measuring the sharp drop in thermal reflection. Imagine standing on the edge of a blindingly white salt flat, looking out over a vast expanse of dark, weathered asphalt. That is the visual and thermal contrast on Pluto. It perfectly illustrates the duality of planetary geology. A common myth is that planets are uniform spheres of a single material. Pluto shows us that a single world can hold vast, conflicting landscapes. A landscape of constant renewal next to a landscape of ancient scars. It is the yin and yang of the outer solar system, a perfect balance of light and dark, youth and age, ice and organic dust. As you visualize this striking boundary, feel the balance it represents. Even in the chaos of space, there is harmony in contrast. Unlocking the origin story. Why do we spend so much time and money pointing a multi-billion-dollar telescope at a freezing rock? Because Pluto is a time capsule. The inner planets, like Earth, Venus, and Mars, have been baked by the sun. They have been melted, reformed, and completely altered since the solar system was born 4.5 billion years ago. But the Kuiper Belt is a deep freeze. Objects here have remained largely unchanged since the dawn of our cosmic neighborhood. When James Webb reads the chemical signature of Pluto's ice, it is reading the original recipe of the solar system. It is looking at the pristine materials that eventually clump together to form everything we know. The water you drink, the iron in your blood, the carbon in your cells. The raw ingredients for all of it exist in their most ancient, undisturbed form out in the dark. A brilliant illustration of this is finding an ancient, perfectly preserved manuscript in a forgotten library. Pluto is that manuscript. It debunks the myth that looking far away only tells us about distant things. Looking far away tells us about ourselves. It tells us where we came from. Webb is the ultimate historian, slowly translating a language of ice and dust. Let the profundity of that thought settle in your mind. By looking at the coldest, most distant edge of our solar system, we are looking back in time. We are finding our own roots, frozen in the beautiful, silent dark. The marvel of the MIRI instrument. Let us take a moment to appreciate the specific technology making this possible. One of the most critical tools on the James Webb Space Telescope is called MIRI, the mid-infrared instrument. While other cameras on Webb look at near-infrared light, MIRI looks at the longer wavelengths. It looks at the truly cold stuff. To do this, MIRI has to be cooled to -447 degrees Fahrenheit. That is just degrees above absolute zero. It is essentially the coldest thing in space, artificially cooled by an incredibly complex cryogenic system. When MIRI looks at Pluto, it is detecting the faintest whispers of heat radiating from the ice. It is MIRI that can tell us exactly what kind of ice is glowing in the dark night. Imagine trying to hear a pin drop in a crowded stadium. Now imagine having a microphone so advanced that it perfectly isolates that single sound. That is what MIRI does with thermal radiation. There is a common myth that space telescopes just point and shoot like a digital camera. In reality, they are complex, delicate thermodynamic miracles. They are triumphs of human engineering. The fact that a machine built by human hands is floating 1,000,000 miles from Earth, kept artificially freezing so it can detect the warmth of a dwarf planet 3 billion miles away, is simply astonishing. It is a testament to our relentless pursuit of knowledge, a beautiful mechanical eye open to the invisible wonders of the deep. The silence of the vacuum. As Webb observes Pluto, it does so in an environment of absolute silence. On Earth, we are constantly bombarded by noise, the wind, the traffic, the hum of electricity. Even in the quietest room, you hear your own heartbeat. But in the space between Earth and Pluto, There is no air to carry sound. There is a pure, unadulterated silence. It is a silence so deep it is almost physical. When we look at the breathtaking images of Pluto's ice mountains and massive plains, we must project this silence onto them. There is no howling wind sweeping across Sputnik Planitia. There is no thunder when a cryovolcano erupts. It is a world of dramatic, sweeping geological changes happening in total, eerie silence. An illustration of this would be watching an incredibly powerful storm through a thick, soundproof window. You see the massive release of energy, but your ears register perfect calm. This shatters the earthly myth that power and action must be loud. In the universe, the most massive forces operate in absolute quiet. Gravity moves planets without a sound. Ice mountains rise in silence. Let the thought of this profound cosmic silence wash over you. Use it to drown out the noise of your day. Imagine floating above Pluto, watching the nitrogen glaciers slowly churn, enveloped in a perfect, unbreakable quiet. It is the ultimate form of planetary meditation. A world devoid of sunsets. We spoke earlier of the eternal twilight on Pluto. Let us delve deeper into the visual experience of standing on this distant world. Because Pluto rotates very slowly, a single day lasts for over 6 Earth days. If you stood on the surface, you would experience a long, drawn-out period of this dim, silvery light. But the concept of a sunset is very different here. On Earth, the thick atmosphere scatters light, creating brilliant reds, oranges, and purples as the sun dips below the horizon. On Pluto, the atmosphere is incredibly thin. The sun does not burst into fiery colors. Instead, the bright, star-like sun would simply shrink and disappear behind the icy horizon. The transition from day to night would be subtle. The silvery twilight would simply fade into the absolute black of space, revealing an impossibly dense field of stars. The Milky Way would stretch across the sky in stunning, uninterrupted brilliance, brighter than you could ever see from Earth. A myth we often harbor is that Earth has the most beautiful skies, but beauty is relative. The sky of Pluto offers a raw, unfiltered view of the galaxy. It is a window into the infinite, unimpeded by thick clouds or light pollution. Imagine lying back on a bed of nitrogen snow, watching the center of our galaxy glow against a pitch-black canvas. It is a vision of pure, stark beauty, a reminder of our tiny place in a grand, sparkling cosmos. The legacy of New Horizons. We cannot talk about James Webb's observations of Pluto without acknowledging the Pathfinder, the New Horizons probe. Launched in 2006, it spent 9 years traveling through the empty void just to get a few hours of close-up data. It was a flyby, a brilliant, fleeting moment in planetary exploration. New Horizons gave us the maps. It gave us the stunning visual imagery of the heart, the mountains, and the dark craters. It fundamentally changed our view of the outer solar system. But New Horizons is now billions of miles past Pluto, heading into the interstellar dark. It cannot go back. This is where James Webb steps in. Webb does not need to fly billions of miles. It sits comfortably at its observation point near Earth and uses its massive mirrors to bridge the gap. Think of New Horizons as an explorer who mapped a new continent from a fast-moving train. James Webb is the scholar who sits in an observatory with a powerful telescope, studying that continent for years. We often believe the myth that flybys are the end of the story, but they are just the beginning. Webb is taking the foundation built by New Horizons and expanding it into the infrared. It is adding layers of thermal and chemical depth to the visual maps. It is a beautiful collaboration across time and space. Two incredible machines built decades apart, working together to unveil the secrets of the underworld. The fragility of the atmosphere. Let us return to the delicate breathing of Pluto's atmosphere. Webb's instruments are closely monitoring the atmospheric pressure. This is a critical measurement. As Pluto slowly moves further from the Sun on its long elliptical orbit, the temperatures will continue to drop. Scientists predict that eventually, the entire atmosphere may freeze and fall to the ground as a thick layer of frost. The planet will go completely silent, wrapped in a solid blanket of its own air. It will wait in this frozen state for decades, until its orbit brings it back toward the Sun, and the atmosphere sublimates into gas once again. This is one of the most fragile and delicate planetary processes we have ever witnessed. An illustration of this is a desert that blooms with life for 1 week after a rare rain, only to return to dry sand for years. Pluto's atmosphere is that rare bloom. Webb is capturing this fleeting moment. It is watching the atmosphere before it collapses into the long winter. This debunks the myth that planetary atmospheres are permanent fixtures. They are fluid, changing systems entirely dependent on the delicate balance of solar radiation. The thought of an entire sky freezing and falling as snow is both melancholic and profoundly beautiful. It is a reminder of the fleeting nature of all things in the universe. Everything has a season, even the air on a distant dwarf planet. The mystery of the bladed terrain. Beyond the smooth plains of the Heart and the towering water ice mountains, Pluto holds another geological bizarre landscape. It is known as the bladed terrain. Huge areas of the surface are covered in jagged, towering ridges of methane ice. They look like massive knife blades pointing toward the sky, some reaching hundreds of feet high. These formations are utterly alien. Nothing like them exists on Earth. James Webb's infrared spectroscopy is crucial for understanding how these blades formed. The current theory is that they are shaped by a process called sublimation. The methane ice turns directly into gas under the faint warmth of the Sun, eroding the ice into sharp, penitent-like structures over millions of years. Imagine walking through a forest, but instead of trees, you are surrounded by towering, razor-sharp shards of glowing blue ice. It is a landscape that feels dangerous, yet mathematically perfect. A common myth is that weathering and erosion only happen where there is wind and flowing water. Pluto's bladed terrain proves that radiation and a vacuum can carve landscapes just as dramatically. Webb maps the thermal signatures of these blades, helping us understand the slow, relentless sculpting power of the cosmos. As you visualize these towering ice blades, feel the slow passage of time required to carve them, a slow, artistic process driven by the faintest whispers of sunlight across millions of years. The connection to Triton. To truly understand Pluto, scientists often look at a completely different world. Neptune's largest moon, Triton. Triton is a rogue. It orbits Neptune backward and is believed to be a captured Kuiper Belt object. Essentially, Triton is Pluto's long-lost sibling, snatched out of the dark by the gravity of a gas giant. James Webb is observing both of these worlds, comparing their infrared signatures. It is like a cosmic DNA test. Both worlds have active nitrogen geysers, both have thin atmospheres, both are incredibly cold. By comparing Webb's data on Pluto with its data on Triton, scientists can build a complete picture of what Kuiper Belt objects are made of and how they behave in different environments. Think of two twins separated at birth. One stayed in the quiet countryside, the other was pulled into the chaotic gravity of a massive city. Comparing them tells you about their inherent nature. This beautifully dispels the myth that planets exist in isolation. The solar system is an interconnected web of captured objects, shared materials and common origins. Webb's sweeping infrared gaze connects the dots across billions of miles. It weaves the disparate pieces of the outer solar system into a single, cohesive story. As you drift through these thoughts, appreciate the deep, unseen connections that bind the universe together. Everything is related. Everything is part of the same ancient, cosmic family. The data transmission, a whisper in the dark. Let us marvel at how we are even seeing these images. The process of getting data from James Webb back to Earth is a slow, methodical miracle. Webb sits a million miles away from us. When it captures the infrared photons from Pluto, it translates them into digital code, ones and zeros. This code is then beamed back to Earth using high-frequency radio waves. These waves travel at the speed of light, but the amount of data is massive, and the signal must be caught by massive radio dishes on Earth, part of the deep space network. It is a slow, continuous whisper across a million miles of empty space. Imagine trying to send a massive, high-definition photograph by whispering a long string of numbers across a canyon. That is essentially what Webb is doing. A common myth is that space data arrives instantly, like a live video feed. In reality, it requires immense patience. The data trickles in, packet by packet, over hours and days. Scientists wait with bated breath as the image slowly assembles on their screens. This slow transmission perfectly matches the serene, unhurried nature of the cosmos. There is no rush in space. The universe operates on its own time. The slow, steady download of Webb's data is a beautiful lesson in patience. It teaches us to slow down, to wait, and to appreciate the profound difficulty of reaching out into the dark. It is a quiet, digital heartbeat connecting humanity to the stars. A new philosophical perspective. As we process all this incredible data from James Webb, we must ask ourselves what it all means. It is not just about mapping ice and counting methane molecules. It is about fundamentally shifting our perspective. For all of human history, the edge of the solar system was a terrifying void, a place where the light died and the cold ruled supreme. But Webb has shown us that this is a lie. The edge is not dead. It is beautiful. It is dynamic. It is painted with organic snow, carved by hidden oceans, and alive with the slow churn of nitrogen glaciers. It proves that the universe is infinitely creative. It illustrates that even in the most extreme, seemingly hostile environments, there is order, chemistry, and profound beauty. This destroys the myth that the universe is entirely hostile and empty. The universe is a canvas, and nature paints on it using whatever materials are available. If it only has freezing gas and a faint star, it paints a masterpiece like Pluto. This realization should bring a deep sense of peace. We live in a universe that tends toward beauty and complexity, no matter where you look. As you gaze up at the night sky, you no longer have to imagine a dark, empty void beyond the planets. You can imagine a thriving, silent underworld of ice and wonder, a place of eternal twilight and hidden oceans, a place that James Webb has finally brought into the light. Preparing for the next target. Our journey to Pluto through the golden eyes of James Webb is just the beginning. The telescope's gaze will not linger here forever. There are thousands of other objects in the Kuiper Belt waiting to be explored. Makemake, Haumea, Eris. Worlds with strange shapes, unknown compositions, and deep mysteries of their own. Webb's observations of Pluto serve as the calibration point, the gold standard for understanding how to read the infrared signals of the deep dark. As we finish analyzing the heartbeat of Pluto, Webb is slowly turning its massive mirrors to peer even further out. It is looking beyond the ice, into the primordial dust clouds where the very first stars were born. Think of a grand cosmic library. We have just finished reading a masterpiece in the planetary section, and now we are walking down the aisle to the history of the early universe. The myth that we will run out of things to discover is beautifully shattered every time Webb opens its shutter. The cosmos is infinitely deep. The secrets are endless. As our minds drift back from the frozen edge of the solar system, we bring with us a newfound appreciation for the dark. We know now that it is not empty. It is waiting to be seen. It is waiting for the right light. Let the slow, deliberate turn of the telescope inspire your own curiosity. The universe is vast, it is silent, and it is stunningly beautiful, and we are just beginning to open our eyes. As our journey to the edge of the solar system comes to an end, take a moment to reflect on what we have seen. We have traveled 3 billion miles into the freezing dark, only to find a world that is breathtakingly alive. Through the golden infrared eyes of the James Webb Space Telescope, Pluto is no longer a blurry, forgotten rock. It is a masterpiece of towering ice mountains, churning nitrogen glaciers, and hidden, dark oceans. It is a world that breathes with the seasons, paints itself with organic snow, and dances gracefully with its companion moons in the eternal twilight. We have learned that the universe, even in its coldest and most remote corners, is filled with profound beauty and silent harmony. The vast distances and the deep vacuum are not empty voids to be feared, but quiet sanctuaries where the history of our cosmic origins is perfectly preserved. Thank you for joining us on this peaceful voyage through the stars. If you found a moment of tranquility and wonder in this journey, please subscribe to the channel and give this video a like. And now we turn the question to you. If you could command the James Webb Space Telescope for one day, which mysterious corner of the universe would you look at next? Let us know in the comments below. Until next time, keep looking up and never stop dreaming of the infinite.